older ideas of Kaluza and Klein, this is what string theory says about the extra dimensions. They have a very rich, intertwined geometry. This is an example of something known as a Calabi-Yau shape. Name isn't all that important, but as you can see, the extra dimensions fold in on themselves and intertwine in a very interesting shape, interesting structure. And the idea is that if this is what the extra dimensions look like, then the microscopic landscape of our universe all around us would look like this on the tiniest of scales. When you swing your hand, you'd be moving around these extra dimensions over and over again, but they're so small that we wouldn't know it. So what is the physical implication, though, relevant to those 20 numbers? Consider this. If you look at the instrument, a French horn, notice that the vibrations of the airstreams are affected by the shape of the instrument. Now, in string theory, all of the numbers are reflections of the way strings can vibrate. So just as those airstreams are affected by the twists and turns in the instrument, strings themselves will be affected by the vibrational patterns and the geometry within which they are moving. So let me bring some strings into the story. And if you watch these little fellas vibrating around, they'll be here in a second right there, notice that the way they vibrate is affected by the geometry of the extra dimensions. So if we knew exactly what the extra dimensions look like, we don't yet, but if we did, we should be able to calculate the allowed notes, the allowed vibrational patterns. And if we could calculate the allowed vibrational patterns, we should be able to calculate